For the following three reactions, consider whether the reactions will occur. If so, write the balanced molecular equation and the net ionic equation only. And we do not need to show the full ionic equation, but we need to show the state for each and every substance. So the key thing is we need to determine whether the reaction will occur or not. So what does this mean? The reaction will occur. So the reaction here means chemical reactions. Only if we have some new compounds produced, then we'll have the reactions. Otherwise, if nothing chemically produced through the mixture of the compounds, then we will not have the reactions. So now let's go through these three reactions one by one. Reaction 1. The first one is potassium phosphate in water solution, aqueous solution, react a mixture mixed with strontium nitrate, also in aqueous solution. And for this situation, we need to use solubility rule to determine whether we have a reaction or not. From solubility rule, we know that anything containing potassium plus cation will be soluble. So anything here will not precipitate with potassium cations. Also, we know that anything with nitrate will be soluble, or nitrate ions. So any ion will not precipitate with nitrate. So we can rule out these two ions. How about phosphate? For phosphate, we know that it generally forms insoluble compounds unless it forms the ionic compounds with unless it forms the ionic compounds with alkali metal ions. So therefore, we know that phosphate will precipitate with strontium ions. As a result, we have the product as strontium phosphate as precipitate and potassium nitrate in solution. So we have 3 strontium here to balance the reactions. We have a 3, put 3 in here. Then let's see. So it gives us 6 nitrate compound, nitrate ions. So we put 6 in for these compounds. And to balance the phosphate, to balance the potassium and phosphate, we need to put number 2 in here. So this is balanced. So pay attention to the status of each compound. So to write the net ionic reactions, we'll skip the part to write the whole ionic equations. As a result, what we have is 2 phosphate anion react with 3 strontium cation. We got our precipitate strontium phosphate, and that's for reaction 1. Balanced molecular equation and net ionic equation. How about the next reaction 2? Potassium chloride mixed with solution of water solution, aqueous solution of potassium chloride mixed with magnesium nitrate aqueous solution. From solubility rule, we know that nothing will precipitate with potassium cation. Nothing will precipitate with nitrate. And most of the ionic compounds with chloride is soluble unless with 3 metals, that is silver, lead, and mercury 1. And we have the magnesium 2+ here. So do we have any precipitate? The answer is no. And do we have any gas produced? The answer is no. So therefore, do we have reaction for this? Do we have chemical reactions for this situation? The answer is no. So therefore, we see there's no reaction. Okay, so the last one. Potassium hydroxide react with phosphoric acid. So here we have a strong base react with weak acid. We definitely have the reactions. Base react with acid will produce salt, ionic compounds, and water. So the product is potassium phosphate in solution because it's soluble plus water in liquid. So to balance these reactions, we need to have 3 potassium hydroxide to balance hydroxide and 1 phosphoric acid, and we have 3 water produced. For the net ionic equation, we need to be careful. So we know sodium hydroxide is strong electrolyte. It dissociates completely. But phosphoric acid, this is a weak acid. That means the dissociation of this acid is incomplete. Means most of the acid forms the molecule in water solutions. So therefore, the net ionic equation for these reactions is actually hydroxide ion react with phosphoric acid to produce phosphate ion and water. And this is the final result.